log word problems that comes up a lot is earthquake magnitude questions. Now, they can ask them in many different ways. And they'll give you sometimes a formula, but it's like 18 steps away from a really easy formula. So whenever I get an earthquake magnitude question, I always use the formula that I have memorized. I don't use what they give me. So the earthquake, and it's only earthquake magnitudes. If it's something that says magnitude, but it's not earthquakes, you can't assume this formula works. It only works with earthquake magnitudes, okay? Because earthquakes on a Richter scale are base 10 magnitudes, so that's why I can use that. And a base 10 magnitude means, like, if you have a 5.0 earthquake and then a 6.0 earthquake, you might think, oh, that's not that much. It's 10 times as intense. So 5 to 6 sounds like very little on a Richter scale. It can be like from like, it rumbled a bit to like everything is completely gone on a 10 scale, right? So 5 to 7 is 100 times as intense. If you think of something being 100 times as intense, that's crazy. How much more intense is that, right? So something shaking like this, if it's 100 times as intense as this, that's chaos, right? So you lose everything. So the equation that we use is capital I equals 10 to the m1 minus m2. And remember, your cumulative assignment number 3 is due tomorrow. All right. So earthquake magnitudes, I equals m1 minus m2. Now this is the catch. If I is a large intensity, so if I is greater than 1, so we'll say a large intensity, so it means it's getting bigger. So it's twice as intense, or 3 times as intense, or 7 times as intense, or 100 times as intense. That's a large intensity, right? It's growing. Then M1 is your larger earthquake magnitude. Large earthquake, or large intensity, larger earthquake magnitude comes first. Then if your intensity is decreasing, or a small intensity, so 0 and between 1, 0 and 1, so half as intense, a quarter is intense, 3/4 as intense, means it's like not as intense as the other one, right? So it's a small intensity. Then your smaller earthquake comes first as M1. And remember, we're going to start spending the first part of the class reviewing all exponential and log stuff while we go through sinusoidal graphs, because the test is going to be on both. So, I equals 10 to the m1 minus m2. Let's talk about a question. So, an earthquake with a magnitude of 7.1, crazy earthquake, is 20 times as intense as a second earthquake. Determine the magnitude of the second earthquake. I forgot the board doesn't extend. That's awesome. I'll do it up here. New smart notebook. I haven't figured out how to extend it. They took away the extended page. It's really frustrating. All right. So we have to decide which magnitude are we given, M1 or M2. And we can only decide that based off of the intensity. So what is the intensity? Which number represents intensity?
Pi.
Which number represents intensity?
20.
20. It says an earthquake with a magnitude of 7.1 is 20 times as intense. So my intensity equals 20. So then I know M1 has to be the larger because that's greater than 1. If this is greater than 1, M1 is the larger, M2 is the smaller. So, did they give us the larger or are they asking for the larger? Let's read. An earthquake with a magnitude of 7.1 is 20 times as intense as a second earthquake. So did they give me the bigger one or the smaller one? An earthquake with a magnitude of 7.1 is 20 times as intense as a second earthquake. That's what they give me. The bigger one. So they gave me M1. And M2 is the one I'm looking for, right? Now, sometimes they give me the bigger, and sometimes they give me the smaller. There's no saying you have to do the bigger or have to do the smaller. The catch, though, is that if your intensity is greater than 1, M1 is the bigger, and if your intensity is between 0 and 1, M1 is the smaller, right? So we have to decide which one they gave us, and is it M1 being the smaller or M1 being the bigger? So let's fill it in. So we get 20 equals 10 to the M1, which is 7.1, minus M2. Now, I need to get an exponent down. The only way I can do that, there's two ways. Common base. Can I common base it? Between 10 and 20, is there a common base? 10 and 20, can I make them to something to the same base? No. Because I have 10 and I have 20. 10 squared is 100, right? Like I can't make them be the same base. The base has to be to an exponent. So what's the only other way I can get an exponent down? Convert to an exponential. How do you get the exponent down? You have to convert to a what? What's the only other option? We're in 2 units, a log. It's an exponential, we convert to a log. If it's a log, we convert to exponential, right? That's why the unit has to go together, 2 units, because you can't do them concurrently. So how do I convert this? I do log base what? The base of my log becomes the base of my exponent, or the base of my exponent becomes the base of my log, right? The base stays the same. So this is base 10, so is this. Log base 10 of what? Log base 10 of? 20 equals 7.1 minus M2. You have to remember how to convert. I'm going to pretend that you're all just being quiet and that you actually know what you're doing, because if not, I'm a little scared. The base of your exponent becomes the base of your log. What's with it doesn't stay with it, right? So currently, 7.1 minus M2 is with it. So I'm going to have base 10 of 20, and it's going to always equal my exponent. And then how do I get it by itself? I'm going to subtract 7.1. So now I have log base 10 of 20 minus 7.1 equals negative M2. How do I get rid of the negative? Divide by negative 1. So get your answer and divide by negative 1. Try it out. Everyone should be plugging it in. I put the answer up here, but you should continue till you get the answer, because there's so many of you who I'll see the math is correct on the test and the wrong answer because you've never plugged one in your life and you've waited for the rest of the class to do it, which is not going to work out well in your favor. M2 equals 5.8. Did everyone get that? You have to go log 20 divided by log 10. Hit enter. Minus 7.1. Hit enter. Yeah, which is 5.8. Yeah. Okay, here's one for you guys to try. An earthquake with magnitude, with a magnitude of 4.1 is a quarter as intense as an earthquake of magnitude we have here an earthquake with magnitude 4.1. So we know the magnitude is 4.1. That hasn't changed. But it's a quarter as intense. So that's my intensity. It's a quarter, which means it's small, right? I like how that just changed. Whatever. Okay, cool. Just does what it wants. So it's a quarter as intense. We agree? So is that a small intensity or big intensity? Quarter. It's between 0 and 1. So that's small. So my M1 is the small earthquake. Because if it's a small intensity, M1's small. So let's see what they gave us. An earthquake with a magnitude of 4.1 is a quarter as intense as an earthquake of magnitude what? Did they give me a smaller or bigger earthquake? Smaller. Because 4.1 is a quarter as intense. So they gave me the smaller one, so they gave me M1. So I have a quarter equals 10 to the M1 minus M2. And so I get the M1, oops, is 4.1. So I get log, the base of my log is the base of my exponent, so log base 10 of a quarter equals 4.1 minus M2. Then I have to subtract my 4.1. And then I get log a quarter. Do I have to write the base 10? Or can I just press the log button? I can actually just press the log button because base 10 is log. A log without a base is base 10. We talked about this. Log a quarter minus 4.1 equals negative M2. Then we divide by negative 1. So we'll go log quarter I get 4.7. And you can grade a sentence, right? Okay, I'm giving you 2 questions here that I want you guys to attempt, and then we're going to move on to sinusoidal. This is one of them. So 16, when it's 1 over 16, what can I write it to make it not be 1 over 16? And make it be 16, what's it going to be? 16 to the what? How do I change it from 1 over 16 to 16? 16 to the power of what? No one even called me over, so that's good. If you don't know what to put it to, then none of you did this. This thing called notes, where we did this in the notes, but it's okay. I'll just wait. I don't have to figure it out. Negative 1. We have 2 people to help you. 16 to the negative 1. We did a quarter in class, which was 4 to the negative 1. So we have 16 to the negative x minus 2 equals 8 to the x minus 3. What base can I make them both be? Base 2. 16 is 2 to the 4 to the negative x minus 2, and 8 is 2 to the 3 to the x minus 3. Then I have to remember to distribute that. So I get 2 to the negative 4x minus 2 equals 2 to the 3x minus 9. And then when I have the bases the same, I can set the exponents equal. When we did this in class, I said if I gave you 2 to the 3 equals 2 to the smiley face, 3 would equal smiley face, right? So your exponents equal if your bases are equal. So if this is 2 to some exponent, and this is 2 to some exponent, well, the only way that would be true to be equal is if those exponents equaled each other. So that's what you do next. Then add my 4x over. Negative 2 equals 7x minus 9 plus 9. 7 equals 7x. X equals 1. Yep, what I do.
Isn't it supposed to be negative 4x minus
8? Yep, it should be. Then I have to start erasing. So we get negative 8 equals 7x minus 9. Add 9. 1 7. Now we should know if we're right or not. So say I got a 1 and I was like, sweet, I'm so brilliant. Look at me, I'm smart. And then I go and I put this into my y1 and I put this into my y2 and I do second trace 5, enter, 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 and I get a 7th. Then I'm like, wait a second, I made a mistake in my math, right? Because you can always find out when it says solve, you can always y1, y2, and find out where they intersect. We agree? Every single time, you can check it that way. Now, number 2, I want you to write as a single logarithm. In order to write as a single logarithm, we need to have the same base. Do we have that currently? Yeah? What else do we need? What do we need in the front of each of them? Plus 1s or minus 1s. And how do we get that if we have numbers in front? You do power rule. What's power rule? You take what's in front and it can go to the raise it to an exponent. You just sit and wait for me to do the work for you. That's not what these questions are for. I'm really good at this math. I do it every year for like 3 times. You guys are all just sitting there waiting for me to give you an answer, which is why the test marks suck. They all have the same base. So we can put them together. Anything with the plus 1 in front goes in the top. Anything with the minus 1 in front goes in the bottom. X squared goes in the top. Y cubed goes in the top. X squared goes in the bottom. Y5 goes in the bottom. This cancels off 2 of those, 3 of those. This cancels off 2 of those. When the whole numerator cancels, you're left with a 1. Okay, sinusoidal graphs, these graphs keep going onwards. What they are, oh really? What they are is graphs of trig functions. So what you might get here is you're going to get something, and it's on the bottom of your formula sheet. It's there's two things under sinusoidal functions, literally two. That's it. This and this. These are the two things. This is the equation of which you'll be given. So y equals a sine, and then they go bx plus c plus d. And it's just a sine equation. If I took a trig equation and I graphed it, this is what they would look like. That's it. It's just a trig equation graphed out over time. And they're periodic. So they'll do the same thing over and over and over and over. And there's arrows on the end of these graphs because they go on for life. Like they would just keep going unless I cut the domain of them. Like I said, it has to be between 0 and 180 or 0 and pi. Now the catch for you guys is the entire unit is in radians. What the heck is a radian? A radian is just another exact measure of an angle in degrees. So for example, 180 degrees, which we know is a straight line, is actually equal to pi radians. They're the same thing. They're interchangeable. 360 degrees is 2 pi radians. Okay? It's just a measured angle because we're dealing with word problems. It only makes sense to have them in radians. So that's why the period here, the only other formula on our formula sheet is 2 pi divided by the b of the equation. Okay? But it really doesn't matter. What we need to know is it's an angle that we use that tells us same things in radians as it would be in degrees. So let's look at this graph. The first thing we're going to do is we're going to actually come back to here. We're going to go to the notes part of it. It's like about 5 pages in. So we're giving a little notes section to if I'm given graphs, how do I find these things? So these are notes on graphs, on sinusoidal graphs. So how do we find the amplitude? Well, what the heck is an amplitude? Amplitude is on a graph, on a sinusoidal graph. They might just ask you, what determine the amplitude? That's it. You use it to find the amplitude of the graph. What the heck is an amplitude? The amplitude is half the vertical distance. And it is always positive. Now we could physically count the vertical distance from the min to the max and then cut it in half. Or there's a formula we can memorize. We don't write amp because that's a standard of measurement. We need amplitude. Amplitude is the absolute value, because it's always positive, the absolute value of the max minus the min divided by 2. So now we're going back to the very front page again. So if I want the amplitude of this graph, I can use the formula, the absolute value of the max. What's the highest this graph goes to? 3. Minus the min. What's the lowest this graph goes to? Negative 3. Divided by 2. And 3 minus a minus 3 is a positive. So I get 3 plus 3, which is the absolute value of 6 divided by 2. Absolute value just turns any negative into a positive, because the absolute value definition of the absolute value is just the distance from 0. So negative 6 is 6 from 0, 6 is 6 from 0. So that's why those comes out as positive. So my answer will be 3. Now, how can I check it? Well, I could literally count the vertical distance and divide it by 2. So this is 1, 2, 3, 4, 5, 6. The vertical distance of 6 divided by 2 is 3, correct? So it's the same thing. That formula just does that math for you. But the way to check if your amplitude is right is if you count your amplitude up and you count your amplitude down, they should meet at the same spot because it should be half the vertical distance, correct? So I'm going to go to my minimum and I'm going to count 3 up. 1, 2, 3. And I'm going to go to my maximum and I'm going to count 3 down. 1, 2, 3. And where do they meet at? The x-axis, correct? Draw that line. So they meet at the x-axis. What's the equation of the x-axis? Y equals 0. So I'm going to write that for my own welfare. So I always check my amplitude up, my amplitude down, and then where they meet. And if they meet at the same spot, I'm right. So let's check the amplitude of this one. So the amplitude is the absolute value of the max. What's my maximum on this one? 6. Minus my min. What's my min?
-2.
-2. Divided by 2 is 8 divided by 2, which is 4. Now I know I'm right if I count down it and count up it and they meet at the same spot, correct? Or I count the entire vertical distance cut by 2. So this would take me 2 to 0. 6 more is a vertical distance of 8 divided by 2 is 4. So I'm going to count up 4. 1, 2, 3, 4. I'm going to count down 4. 1, 2, 3, 4. And where are they meeting at? What 2? What is this line? What is the line? Y equals positive 2. Always draw that line in there. I'm not drawing it there for fun. I'm drawing it there because it needs to be there. It will help us later. We're going to skip 3. I want you to try 4, 5, 6, and 7. I want the amplitudes. The amplitude equals the absolute value of the maximum. This one goes to 0.8 minus minimum negative 0.8 divided by 2 is 1.6 divided by 2, which is 0.8. So we count down 0.8, we count up 0.8, and they meet on the x-axis, which makes sense because this graph is symmetrical with the x-axis, which is the equation of y equals 0. This one, my amplitude equals the absolute value of the maximum, which is 4, minus the minimum, which is negative 4, divided by 2 is 8 divided by 2, which is 4. Once again, it's symmetrical, so that makes sense. It means same amount on the top as on the bottom. So if I count down 4, this is 0, then this would have to be 2, this would have to be negative 2. So if I count down 4, I go 2 to 4. I count up 4, 2 to 4. It's meeting at the x-axis, which is y equals 0 again. Now, it doesn't always go to y equals 0. Like that other one we had was not y equals 0 on the previous page, right? It was a different number. It's y equals 0 every time the graph has the same amount above as below. Same amount above as below, you will always get that x-axis being your midline. Okay, here we have the amplitude equals the absolute value of the max minus the min divided by 2, which is 10 divided by 2, which is 5. So I count down 5, count up 5, and I meet at the midline, which is y equals 0. This one, we have the amplitude, which equals the absolute value of the max minus the min, divided by 2, which is 12 over 2, which is 6. So we count down 6, and then we would know that the middle would be at y equals 0. All right. The last thing we're going to do before the end here is we're going to go to the midline. The midline we've actually found every time already. Did we not find the midline? It's that middle line. We already wrote it. But if they ask us for just the midline is the average. If I was finding the average between 2 marks, what would I do? Add the 2 marks up and then divide by 2, correct? If I'm trying to find the average between a max and a min, what am I going to do? Add the min and max and divide by 2. Now, can you see how people could get the formulas mixed up between amplitude? So make sure you think that amplitude is half the vertical distance, so I have to subtract, and it's always positive. But midline is my average, and what do I do when I find the average of 2 marks? Add them, divide by 2, right? So this is literally looks very similar, but they're not the same. And guess what? Do you think if you mix them up, they'll have the opposite there for the amplitude and midline? Do you think they'll give you the oopsies? Yeah, they will. Okay? So, it's just max plus min divided by 2. No absolute value signs, because it can be negative. So if I do the midline for this one, it's going to be at y equals the max, which is 3, plus the min, which is negative 3, divided by 2, which is 0. And we already have that, y equals 0. It's right here, we found it. We already found the midline every single time, because we count our amplitude down and amplitude up, it meets at the midline. If we look at number 2, our midline is y equals the maximum, which is 6, plus the minimum, which is negative 2, divided by 2, is 4 divided by 2, which is 2. So it's at y equals 2, which I already found, right? We already found it at y equals 2. So do we have to use the formula to get the midline? Or could we count up our amplitude and down our amplitude and find our midline? Both ways work. Same thing. Do I need to find the formula? Do I need to use the formula to get the amplitude? No. I could count the vertical distance from bottom to top and just divide it by 2, and it would be the same, right?